charts. We have seen dot charts. Now we'll get into bar charts. So we'll understand how to use bar charts effectively. So there are simple bar charts, there are horizontal charts, there are stacked bar charts, grouped bar plots. You would have seen all of these in Excel. Obviously Excel is more adept at handling all these things, right? But right now we'll go ahead and see how we will construct these. So a simple bar plot, so I'm just going to create a counts column, counts frame, and I'm saying table, right? What I'm trying to do is I'm just converting the empty cars data, and in that you have something like as gears. So a table function basically creates a confusion matrix, right? So it would do a summarization basis the gears in this case, right? So do that. So you can have a look at counts. Just refer to the wrong column name. Okay, so this is how it is. There is 3 gear vehicle, 4 gear vehicle, and 5 gear vehicle. So 15 are in 3, 12 are in 4, and 5 are in 5, right? And now if you want to see a plot of this, you can say bar plot. Okay, and you can say counts, comma, and you can say main is equal to car. So I'm just going to say capital C distribution by gears, right? So before that I have to just make this bar mf row, because once you have initialized, this won't get changed unless and until you close the system again. So just change this again and then run this. So you should be seeing the whole plot now. This is how we will see it, right? You want to just change the form in which it is displayed, right? So you can just add one more parameter. So you can specify that horizontal is equal to true. If you mention this, then it will change. Obviously you have to make some more changes, like names dot argument, so it's specified by names dot arg is equal to C, so that the user can understand what you're saying. 3 gears, and then it would be 4 gears, and then final 5 gears, right? So you can display it in the horizontal form also in this way, right? Depends on how you want to see the data. I'm just wiping this off. And now if you want to add some more color to this, right, so you can go ahead and do the same bar plot, right? So I'm saying counts main is equal to car distribution by gears, and let's change the data a bit, right? So let's say counts not having just one attribute, we are adding 2 attributes. So table empty cars dollar, I can say vs comma empty cars. So we are adding one more dimension, so a confusion matrix which has 2 variables, right? So let's have a look at counts, right? So this is how it is, right? Now 2 dimensions, and then there's a frequency tabulation over there, and then I'm going to use the bar plot again, and this time we're saying counts, it has to show 2 dimensions, and main is equal to car distribution by gears and v/s, and then you'll have to specify x lab, that is what is on the x-axis, is equal to number of gears, and again you'll have to specify on the y-axis also. So I'm specifying color is equal to C. So which colors do you want to see? So it is dark blue, and then you have one more color which is red. So these are the 2 colors you predominantly want to show over here. And you're saying legend, that is nothing but your typical plot legend is row names, and inside that it's counts counts. So fills this up. Just check it once for just matching up the number of. So this is how your chart will look. Incidentally, it is CRA, so you'll have to change this to card distribution. I've just mentioned the title with a little bit of mistake. It should be CAR instead of CRA. Okay, now you can do a grouped bar plot also if you want to go ahead, and in this case you're going to use the same data, the VS versus the gear data, and all you're going to do is you are going to add a beside is equal to true apart from what you have been using. So I'm just going to use the same. I'll just rectify this part over here which was pending, and then I will have to add something over here. So that would basically be nothing but besides is equal to true. Okay, just one sec, there's no S, it's a case sensitive parameter. Okay, now the warnings is coming because the fit size is not correct, but still it is showing you the output, right? Okay, so just close this, and I'm just cleaning the screen and we are moving ahead. Now if you want to visualize data in a pie form, in a pie chart form, right, which basically talks about showing it in a circle which is broken up into different pies to make it more relevant in terms of percentage form or absolute counts, that is where you'll use pie charts. So simple pie charts, pie chart with annotated percentages, that means the percentage is also specified, and then there could be a 3D pie chart with a little bit of elevation and a shadow and all those things. So let's create some data for this. So I'm saying slices, that's the data which we're going to create. C, when I'm saying 10, 12, 4, 16, 8, right? And you're saying LBLS is one more object. When you're saying C is equal to, just specifying the country of origin, US, UK, Australia, can use short forms also, and France. I'm just going to change Australia to AUS, right? And then you can do a pie of this, pie slices, labels is equal to LBLS, when you have saved the country of origin, and main is equal to pie chart of COUNTRIES, right? So this is how the chart will come up. You can zoom it and see, right? Okay, you can make it a little bit more fancy by adding in some colors, right? So what we are going to do is we are going to keep the slices in the LBLS, that is the country of origin, as it is, but we are going to add some more things. So we are saying PCT location sign, so I'm saying round, so you're basically saying the number that is slices has some data divided by sum of slices. So you're basically taking it in a ratio form and then multiplying it with 100 to get it converted into percentage. Right, and then you're saying LBLS allocation, so you're pasting LBLS with PCT, that is percentage, which you have just created. You can have a look at LBLS, right? That's how it will be shown up, right? And then you can say LBLS allocation paste function, you have LBLS as it is with the percentage sign, and just adding a percent in a symbolic form, and then you're saying a comma, and sep is equal to null, so you're making sure that there is no separator, and you're saying add it. Now have a look at LBLS, right? That's how it is shown up. Just keep on adding percentage sign over there, and then you can run the pie function again, slices, comma, labels is equal to LBLS, which is now a transformed form with some percentages mentioned over there, and color is equal to rainbow, So we're specifying the rainbow and saying length is LBLS, right? So you also pass that as a parameter over there, comma, and main is equal to pie chart of COUNTRIS countries. Rest of the things remain as it is, right? So you just added some colors over there, right? Okay. Now furthermore, you can just keep on enhancing this, but for that, if you want a 3D pie chart, then you will require a library called as plotrx, right? So I have to say install dot packages plot rx. I have to just quote it like this, so that you can use it in a 3D form, right? So this should take some time, so just hold on while it gets installed and registered in the registry. Okay, so now I'm going to just use the library plot.trix. Okay, so it's activated. Now the slices data will remain as it is, but LBLS has to be re-changed because you have made a lot of transformation and you have to bring it in the same form, or if you want you can keep it as it is also, right? So I'm just going to go to the very basic form of LBS. So I'm just rewriting the data again. So this is the actual LBLS, right? And I'm saying plot 3D, right? So it's not the simple font, this is slices against labels, wherein you're specifying the labels as LBLS, and then you're saying explode. This is one parameter to the ratio 0.1, comma, and it depends whether you want to specify the headers, and you can say 3D pie chart. So just a 3D chart, the same data, again depends where you want to use it, how you want to use it. You can expand it, zoom it, export it into PDF, and do all sorts of things. Now we'll come to something which is called as a histogram, right? A histogram basically helps us to understand the distribution of data, very relevant in terms of analytics, because it shows the data, whether it's a skewed data or whether it's a normally distributed data, whether there is very high kurtosis and all those things. So it makes sense to use histogram quite often. So the simple form is a hist function, right? So we'll use that, the hist function. So empty cars is the default data which we are using, and in this I'm saying mpg, and when you run this is the histogram, right? So it's a histogram of empty cars. That's how we can see it. It's a simple histogram, right? Now we can go ahead and do scatter plots also. We have already done some scatter plots, but further if you want you can do some more, right? So we already have the empty cars loaded, but if you don't want to refer with empty cars again and again, I'm saying attach empty cars, so that we can just directly access the variables directly. So we can say a plot of weight versus mpg, that is miles per gallon, and main is equal to scatter plot, right? And it's an example, so we're mentioning as an example. Give some parameters for xlab, and that is how we are defining it. So I'm just going to change this. There's a small mistake over here. Xlab is equal to what would be the label on the x-axis, so you can say it's car weight, right? And then you can say y lab, which you can specify as miles per gallon, because visualization and graphs are for users who typically don't know the variable name, so you might have to specify it also. So this is how your scatter plot is looking, and by default the last one wasn't red, so it is coming up as red.